Now let's look at another example, and to do something a little more involved now. I have this shape right here. Okay, so this is my rigid body, a quarter circle. Okay, and here's where I place my x and y coordinates. Right, so the origin is right here. Now, so this is a quarter circle. Now I have an equation to describe this line right here. Okay, the circumference, which is x squared plus y squared equals r squared. Now r is constant. Okay. All right. So this is r, and this is also r. Okay. So I would like to determine the center of gravity or centroid of this shape right here. Okay. Now, just by looking at it, if there's a piece of material like this, right, or like a plate, right, this is shaped like a quarter circle. Just by feel, you guess that center of gravity should be like somewhere like around here, right? Okay. Now, center of gravity. Now, what I think about center of gravity is that you take any shape, right? You were to balance the shape on your finger. That's where center of gravity is located. Okay. So if you were to take this shape and balance it, that's the center of gravity or centroid. So now I like to determine the precise location, right, or x bar and y bar of that point. So I'm going to use the exact same equation. Right? And like I said in the last example, in order to carry out this integration, there are three ways to do this. Right? You can split it into tiny elements, okay, each individual element, and integrate the x and the y, so it's double integration. Or you can define vertical or horizontal strip. It's up to you. Here I'm going to use a vertical strip. Okay, so define a strip, and then I'm going to sweep it from here all the way to this location. Now, as long as I cover the entire area, then I'm good. Okay, so for this strip right here, I have width of dx, okay, and the height of this strip right here, okay, is measured from 0, okay, y equals 0, all the way up where it hits this curve, which is y. So the height is y. Okay, so it's a y coordinate. Okay. And what else? Let's see. What else do we need? We need x tilde and y tilde, right, of this strip right here. And for this thin strip, you know exactly where the centroid is for the strip. It's right here, okay, halfway down. Okay. So this is my x tilde, and this is my y tilde for the strip. Okay, so now let's write down everything. Right? So for x tilde, what is it? X tilde is exactly x. It's simply x, because it's measured from 0 to x coordinate, the x location. So it's exactly what equals x. Y tilde, the centroid location, right? The y coordinate for the centroid of the elements of strips is exactly 1/2 of the height of the strip, which is 1/2 of y. Okay. And what else? Oh, we need dA, right? Elemental area. So the area of this guy is simply the height, which is y, times dx. So y dx. Okay? Here, from this equation, right, I can rewrite in this form, y equals, right? So just move everything over, take square root, so this becomes r squared minus x squared. So that's my y. Okay. So I have these 3 plus this guy right here. So now, put everything into these 2 equations. Okay, and see what it looks like. Alright, I'm going to do x bar. So, x tilde dA over area. Now, just to keep things a little cleaner, I'm just going to calculate this guy separately. Okay? So, which is the first moment. Alright? So, let's calculate this first moment. Alright. Replace everything in here. X tilde is x. dA is y dx. Alright? So far, no problem. Pretty straightforward. Okay. Now, in order to carry out this integration, we need to replace y in terms of x. Okay? Because right now we can't really perform this integration, right? So I need to bring in this equation right here into here. So y equals square root of r squared minus x squared dx. Okay. Now, this form of integral, you should be able to evaluate it, okay? Because everything in here is x now, and it's integrated with respect to dx. Okay? Now, this might look a little complicated. However, if you remember from calculus, integration by parts. Okay? You get by part, what does that mean? Look at this right here. This guy, this x, right? It's related to what's in here. Specifically, what's this right here. Right? Now, when you differentiate x squared, you get 2x, right? But particularly, it's minus. Okay? Minus sign needs to be taken into consideration too, so it becomes minus 2x, right? So I have x out here. So I'm almost complete. I'm almost okay, right? Now, if this is negative 2x, then I'm okay in here. Then I can do the integration, no problem. Right? So let's do it by part. How you do integration by part is that you define a quantity called u. Okay? So let u be what's inside of this square root, which is r squared minus x squared. Okay? So what happens here? So du becomes, well, take the du of the whole thing, okay, and then d, this guy right here. Now r is a constant, so d constant is 0. Right? So what's left is this guy right here. So you differentiate this guy, so minus 2x dx. Okay? So you have this right here, and I need to also define the lower and upper limits, okay, to fill in this. Okay? And so out here, when you integrate with respect to dx, you're integrating from x equals 0 to this location, which is r. So that's 0, r. So when x equals 0, what happens to u? Okay, because eventually you're going to replace x with u. Right? So when x equals 0, just plug it in here. Okay, when x equals 0, u equals r squared. And when x equals r, what happens here? U equals 0. Okay? So that's for the limits. So now you can replace everything in here with what you define out here. Right? So this now becomes, alright, so I have square root, right? Let's first do this. Okay, I would like to have negative 2x out here. Okay, so what I do here is multiply by negative 2, and then I need to divide by negative 2. Okay, so now integrate by part, so the whole thing here, bring it in here, replace it in. Okay, so I have negative 1/2. This right here is simply square root of u. Okay, so this is square root of u, and this and that is this guy right here. See? So this is exactly du. Okay? So substitute everything in here. So now look at this integral now. That's easy. That's very easy. Right? Except now the limits, will no longer be the limits for x. Now it's the limits for u. The lower limits for u, is from r squared to 0. Okay. So now square root of u is u raised to the power of 1/2. Okay. So 1/2. Square 0, so u, right? That was 1/2 u. So do this integration, negative 1/2. So this plus 1 becomes 2/2 divided by 3/2, which is 2 times 2. Okay, from our square to 0. Do this. 2 and 2 cancel out. This equals minus. Bring this in here. So this is 0. The whole thing is 0. Minus. Bring r squared in here. So that's your r squared raised to the power 32. Okay. So 0 is 0. Negative become positive. So this is r third, and don't forget the 1/3. Okay, so actually I have 1/3 out here. So there you go. There you go. Because this guy survives, right? So, all right. There you go. So this is x bar location. Okay. So simply 1/3, of the r third. Okay. Now, erase this. So what this is the first moment, right? So therefore, replace it back into this original equation. So x bar equals, in here, so 1/3 of r third divided by area of this quarter circle, right?